Hi, Jamie Patton here with the Nutrient and Pest Management Program to talk a little bit about soil pH. If you ask a soil scientist what one piece of information they would want to know about a soil in order to make interpretations about how it's functioning, many soil scientists would say, give me soil pH. And the reason for that is soil pH is going to dramatically influence not only the biological, but the chemical and the physical processes going on within a particular soil. So that soil pH influences so many different properties. It's going to influence soil health, and it's going to influence how well our crops are going to grow under agronomic situations. So in times of high fertilizer prices, such as we're experiencing right now, it is imperative that we keep our soil pH in a range that's ideal for a particular crop. And the reason for that is kind of explained in this chart. And I like this chart because it's really visual. So when we look at the bottom axes, you notice the pHs are ranging from 4 to 10. And there are listed different soil nutrients within the chart, and those nutrients are contained within bars. When those bars are wide and they're green, that means that those nutrients are more available for plants. And as those bars begin to get thinner and change from green to yellow to red color, that means that that nutrient availability is decreasing. So just because a nutrient is contained within a soil does not mean that a plant can take it up. That nutrient has to be dissolved in water. But soils are complex in that there's lots of different chemical reactions going on. And so by maintaining a soil pH within a particular range for a particular nutrient, we're going to help ensure that that nutrient stays dissolved, not solid, but rather dissolved, so that that plant root can take it up. And what's really interesting is when we look at those nutrients, macro versus micronutrients, they're going to follow different patterns within the soil. So if you look at the top 6 nutrients in this figure, nitrogen, phosphorus, potassium, sulfur, calcium, and magnesium, all of those are considered macronutrients. You'll notice that their bars are widest and greenest when that pH is near 7. So when soils are near neutral, our macronutrients are most available. Alternatively, our micronutrients, so that iron, manganese, boron, copper, and zinc, are going to be more available when that pH is closer to 5.5. Molybdenum doesn't follow the typical micronutrient pattern, but a majority of those micros, as you notice, those 5 listed right there, are going to be most available at those lower pHs. So for us as agronomists, trying to balance this complex chemical environment and maintain the availability of both macro and micronutrients is essential to ensuring not only fertilizer use efficiency, but also crop growth and productivity. So in the state of Wisconsin, you're going to see many of our target soil pHs for particular crops are going to range somewhere between 6 and 7. So the target pH range for corn and wheat in Wisconsin is 6.0, for soybeans at 6.3, and alfalfa at 6.8. Our legume crops, such as alfalfas and clovers, are going to have that higher target pH because not only are we trying to maintain nutrient availability, but we're also trying to create an environment that's conducive for rhizobium growth. So those nitrogen fixing bacteria that live with those legumes are going to like those higher pHs, or be more prolific and more productive at those higher pHs. In addition, alfalfa is very, very sensitive to aluminum, and aluminum, it becomes toxic as those pHs drop near 5.5 or below. So there's a lot of complexity in managing the soil chemistry within a given environment in order to maintain nutrient availability. In times of high fertilizer prices, it is essential that we maintain soil pH so that the little bit of fertilizer that we may be applying, because either supplies are limited or we are choosing not to buy as much nutrient as we would have in the past because of higher prices, it is essential that we're applying those to soils that have a pH that's going to maintain that availability for crop uptake. So when we look at liming our soils, in order to make those lime recommendations and figure out how much lime we need to apply in order to bring that soil pH up into that target pH range for my crop rotation, I'm going to need to have an up-to-date soil test. And that soil test is going to give me lime recommendations for oftentimes the 60-69 effective neutralizing material lime, as well as that 80-89 effective neutralizing material lime. Common liming materials in Wisconsin include the calcium and or magnesium carbonates, so the calcite, as well as dolomite limestones, which are mined from the ground to a particular fineness and then applied to the field. So it's important when we look at these lime applications that we use a lime Products such as calcium chloride and calcium sulfate, also known as gypsum, are not liming materials. Limes must contain a base cation, but also neutralize acidity. So gypsum, for example, contains calcium, contains that base cation, but the sulfate portion doesn't neutralize that acidity and pH doesn't change. It's also important in when we're looking at our potential lime options that these materials must be applied in sufficient amounts. So there's a lot of products out there that say you only need to apply maybe 100 pounds of this product to see that pH go up. Most oftentimes that is not true. We're oftentimes applying tons of a material, a ton or more plus of the material in order to neutralize that acidity. There's a lot of acid out there as that pH drops below that target pH of 6. And so we need to apply an appropriate amount of lime to neutralize it. So if a product seems too good to be true, it probably is. But if you don't know, go ahead and ask your agronomist, extension agent, and state extension specialist, and we can help you with those questions. So in times of high fertilizer prices such as now, what is the key takeaway from this presentation? pH is important. And so the old adage, the first dime on lime, may hold true, right? If we want to make sure that that nutrient stays, that we're spending a lot of money on, stays soluble and available for nutrient uptake, we need to ensure our soil pH is in a range that allows for that.